Hey everybody! Welcome to our first set of notes for the year. This year I am flipping my classroom, and that means that rather than me standing in front of you and lecturing during the class, you're going to watch this either at home or at school, and you'll be doing your notes that way. That way when you are in the classroom and have time to work with me, I will give you 100% of my attention. Anyways, first set of notes for the year, scientific method vocabulary. You guys learned all about scientific method in elementary, 6th grade, 7th grade, and now here we are in 8th grade and we are still learning about it. So I'm going to rush over all the steps in the scientific method because I'm quite certain that you guys maybe need a refresher, but I'm pretty sure that you guys remember hearing about all of this stuff. So here we go. As we take notes, I want you to start by writing the title at the top of the page. And remember that you can pause the video at any time if I am moving too fast for you. So go ahead, copy the title down, and I'm going to move on. You guys can pause at any time. What is the purpose of today's lesson? Well, I want to remind you guys about the scientific method, all of the steps, but basically what we really want to get into is the meat and potatoes of scientific method and experimentation and variables and how to write a hypothesis, all those kinds of things about what makes a good experiment good or valid. So we're going to learn a lot of vocabulary. We're going to correctly write a hypothesis, and then we are also going to learn some important things about the variables in an experiment. Now, here are the steps of the scientific method: problem, research, hypothesis, test, analyze, conclude, and communicate. Some of these words may have been taught to you a little bit differently. Some teachers may have called this the question, but the problem is really the question you have that you're trying to solve or figure out. Now, before you start any experiment, you should research a little bit about it, okay? Research, find out if you're experimenting about tomato plants. Make sure you learn a little bit about tomato plants. Maybe somebody has already told you what makes tomatoes grow well. Hypothesis. This is where you decide how the experiment is going to turn out. Is it going to do this if you do that? We'll get more into writing a hypothesis in a bit, but basically you're making an educated guess as to what you think is going to be the answer to your problem. The next step is to test it, or some teachers may have told you to design an experiment, right? So you're going to plan the experiment. You need to figure out what it is that you're going to do, and then you're going to put all of the tests in place. Number 5, analyze. This is where you collect the data. As you are experimenting, you are collecting the data. You're probably putting it into graphs and or into tables. Analyze means that you're going to take all those numbers, all of that data, and you're going to do something with it so that you can understand it better. Maybe you're going to turn it into a graph. The next step is to conclude something. So now that you have all of your data and you've made a graph, you're going to go ahead and decide whether or not your hypothesis was correct. Did you come to the correct conclusion? And 50% of the time, scientists do not have the right hypothesis, and they have to go back and start again, right? But you decide whether your hypothesis is correct or incorrect. And finally, you need to share your results, and that's communicate. So you're going to share the results of your experiment. How do we remember all of these steps? Well, I've got a little trick. I have a little acronym poem. So I've highlighted each of the beginnings of each of these. And so P for problem. Here we start. People really hate termites and creepy cockroaches. There we go. Yummy, yummy cockroaches, termites. All right, so we have some vocabulary here. The first one is hypothesis, and more than the vocabulary part of hypothesis, because we talked about that before, this is how to write a proper hypothesis. You will probably learn in high school to do this a little bit differently, but in middle school, we teach you to write an if-then statement, okay? We will need to put the independent and dependent variable in the spaces, which we will talk about later, but in order to write a hypothesis, we start off with if. Then you say something about your independent variable. Then say something about your dependent variable and because. And this is the reason why you think it's going to happen. All right, we'll practice this a little bit later. Independent variable. This is the part of the experiment or the factor that the scientist is going to control. So if you're doing the experiment, you are the scientist, and it is the part that you are changing in the experiment. For instance, as you can see along the side, there's an experiment here, independent, dependent variable. In this example for independent variable, we have the type of liquid you're giving the plant. So in this picture, the independent variable might be Coca-Cola, or you might change it to juice. Maybe you're going to water it with water. Who knows? The dependent variable of the experiment is the part that you're going to measure. Okay, so in this case, you can see down here, dependent variable is the ruler. So they're going to measure the height of the plant. So this is the measurable part of the experiment that changes as a result of the independent variable. So the height of this plant is going to change depending on what we are giving this plant to drink. If it's Coca-Cola, if it's juice, if it's water, whatever. That height might either grow faster or that plant might actually shrivel up and die depending on what it's being fed. So in this case, the example is how much the plant grows. Controlled variable. In most experiments, we are supposed to only change one variable at a time. Every other part of the experiment that could be changed actually has to stay the same. All right, so in the lesson back here, independent variable, we have decided to change the type of fluid or liquid we are giving the plant. So we are only going to change that part. Everything else has to stay the same. In this case, the type of plant we use, if we're going to start with a tomato plant, all of them have to be tomato plants. We have to keep the same size of pot. We have to give the plants all the same amount of sun. So those are our controlled variables, and our only independent variable, remember we can only change one, the independent variable is only going to be what liquid we give the plant. All right, experimental group. This is the group of plants or people or whatever that is having the experiment done to it. Okay, I have an example. So maybe it's a group of people who are receiving an experimental drug, right? In our tomato plant experiment, our experimental group are all of the plants that are getting juice or Coca-Cola or milk, or what else could we feed it? Ketchup, I don't know. Those are the group of plants that are getting all of the experimental liquids. Control group is the original type of plant. We normally feed plants, or any kind of plant, we feed plants water. So that is our control group. It remains unchanged. If we're going to give the plants 1 cup of water every week, then we have to give 1 cup of Coca-Cola, 1 cup of, I already forget, 1 cup of juice, 1 cup of ketchup, 1 cup of milk, right? So the water group is the control group, and the experimental group is the one that's getting all of the special liquids. If you have a chance in class later, we will be doing a watch it portion, and we will be watching this YouTube video, Controlled Experiments. Number Number 7, vocabulary. Here we have two different kinds of data, quantitative data and qualitative data. Now, notice these words are very similar, so I've circled a part of it because this one has quantitative, this is qualitative. The root word of quantitative is quantity. The root word of quality is qualitative. Quantitative data is anything that you can measure. That might be that you're measuring its weight or its mass, its length, its volume, its pH level, anything that you can measure, all right? The qualitative is a more of a descriptive type of data. You might take data about which is big or small, or you might take some data about after we oiled the part, we heard less squeaking or more squeaking. So it's something that we use our 5 senses. So either our eyes, our ears, our nose, our fingers for feeling, or our taste buds. But again, in scientific labs, we do not taste things unless you're doing a test to see which recipe might taste better. Then you might use your mouth. Anyways, inferences. An inference is, remember back in the scientific method, we talked about at the end, there's the conclusion. So you look at all the data and you come up with a conclusion. Well, your conclusion is based on your personal belief. Okay, you are making an inference based on all of your prior experiences, of your experience, all the things that you've experienced in life. Okay, so that's what an inference is. Validity. All right, we want to know if the experiment that you designed is actually valid. Does it really test what you wanted it to test? Did you take measurements accurately? Which brings us down to number 11, accuracy. Now, accuracy is the true value of a measurement without rounding it off. We can say that you are 13 years old, but an accurate number would be more like you're 13 years and 52 days. That's accuracy. So you take your measurement, whatever it is that you have, here's a ruler with centimeters on it. Now, you'll notice that there are numbers, I don't know where I am, 10, 11, 12, but you also notice that there are little markers in between. And so those markers that are in between help you create a more precise measurement. Just like in this one here on the side, this one here, we know that the red line is not at 100. It's not at 90 either. So we have to look at these little lines in between and show that it's 91, 92, 93, 94, 95, 96, 97, 98, but it's beyond 98. So I can't say that it's exactly 98 point something. I can say 98.550 if I have to put a number in here. That is being accurate. Now we have data. We talked about quantitative and qualitative data on the last slide, but I wanted to mention here that data is often displayed in tables, or it might be displayed as a graph. Often you have to gather your data, put the numbers in your table, and then you can create a graph afterwards. And graphs can be bar graphs, they could be line graphs, they could be pie graphs. There's all different kinds for you guys to remember. Now, let's see if you hit the target. After this lesson, here's what you should be able to do. You should be able to list the steps of the scientific method. Remember, we had that little acronym poem. People really hate termites and creepy cockroaches. Yuck. You should also be able to correctly write a hypothesis with an if, then, because statement. You should be able to compare independent, dependent, and controlled variables. know how to pick them out of an experiment and know which is which. And you should be able to also be able to use the other vocabulary words that we talked about today in a sentence. All right, guys, thanks for joining me. We'll see you next time.